have the account thread function and the audit thread function, which calls the corresponding function from the bank. I have a bank class which has here has the transfer operation, and I use the solution from the course with locking them in the order of the IDs of the account IDs. Here is the audit function, which verifies the balance and then verifies the logs. Here are the two functions.
Can I see again the audit function and how it uses the mutexes?
I was confused here because I didn't understand if I have to use the mutex or not. I tried both ways. I thought that if I lock here, then I was not sure if I need to lock the account when I do the audit as well. I was a bit confused about this. I'm not sure. I think I have to lock this as well. I mean, if I run it without locking, the audit still looks good. It says that it's okay, so I don't know. It says logs okay, balance okay. So I have 10 account threads and 10 audit threads, and I run them at the same time. I start at the same time and wait for them at the same time. And it says, okay, this is without the mutexes. Yeah.
So first of all, global mutex won't help much because it would concern only the audit function. The potential problem is that you look at just a moment. Let's see verify balance. Verify balance. Verify balance.
So each account has an initial balance of 10,000.
And it looks,
because I basically hard coded this, but yeah.
It looks into the log of the account and compares the current balance with the history.
Yeah.
Now, without locking, it should be possible that you either get an operation that adds something to the log while the for each loop is executing. And in that case, the for each loop would break. Typically, you will get an exception.
Yeah. Yeah, so I just got lucky that I didn't get it. Yeah, okay.
Yes. And it's also possible that you get an operation in the log and you don't have the balance updated or the other way around, depending on the order of those two operations in the transfer function.
Yeah, true.
So you should take there the mutex of the account.
Yeah. Yeah.
And for verify logs, would we see verify logs?
Yes.
So on an account, it cross-checks that each operation is found in the opposite log. Now, theoretically, you should also lock the destination or the source account, the peer account. And the problem is how to make sure you don't get a deadlock there. The easiest way to go is the audit to lock all the accounts, do its job, and unlock all the accounts.
Oh yeah, and then the bank will be blocked on the audit. Nothing will happen. It's just
yes.
Yeah.
Okay, but I'm fine with that solution as well. Good.
Okay, thank you.
Thank you also.
Okay, I will share my screen if that's okay.
Yes, please.
Okay, so lab 2. So I have a class which has a method, consume and produce as well. And I create 2 threads. And each of the threads is gonna call a method from that class. So the first thread is gonna call produce, so it's gonna be the producer, and the second one is gonna call consume. And if we go to the class, we have the 2 vectors. I hard-coded them because I just didn't want to ask for them. And I have a lock and a condition. And the condition is created with the lock, so that I don't have to pass it as parameter. Then the first, the produce method is gonna calculate the products. And it's just gonna, it will signal when it's done, and will wait for the consumer to be done. Also, I have a lock and an unlock. I mean, I use the locks right at the beginning and right at the end. Yes, and consume, again, I will have a lock. It waits until I change did produce from here. It will add to the general sum, because I have to make the sum of the products I calculate. And I will print out the sum at every step. It will change the did produce to false, so this one exits here, and it will signal. And I can run it if you want me to.
Yes.
So at the first step, it's 8, because it's 2 times 4, and then it's 8 plus 3 times 6, 26.
Yes. So you have a queue of size 1 between the producer and the consumer.
Excuse me? Can you repeat, please? I didn't hear that.
You have a queue of size 1 between the producer and the consumer.
Yes, I do. Yes, I do.
Good.
Okay, thank you.
Thank you. Okay, Andrei Bursu.
Yep, sharing my screen. This is the one with the matrix multiplication. I've done it in Java because this one has easier thread pools than C++. So I have this matrix class that contains basically a matrix, and it also contains it in flattened form. That will be useful for one of the methods. Yeah, it's done in 3 ways, as the laboratory asked. First, it's trying to split the tasks by taking row by row. So the first task gets n rows, the next one gets the next n rows, and however many elements are left, and so on. And it makes all of them makes use of the same compute element function, which takes the 2 matrices, the row and the column that, or sorry, how should I explain this? It takes the 2 input matrices and the row and column of the element that should be the result. Okay, and then the column 1.
Just a moment. What are the row and col parameters that are given to the task?
Okay, so for the task, it gets the row and column for the first element that should be processed.
Yes.
And then the number to process is how many elements it should process starting from that row and column.
Okay.
And for the row tasks, for the row task, it takes them like element by element, row by row. So I don't know, let's say I pass it 2, 3 for the row and call. Then it will go at 2, 3 and take the next n elements on that row. If it can't find them all, then it will go to the next row and takes the remaining ones and so on until it completes this number to process.
Okay.
For call task, it does the same thing, but instead of going row by row, it goes column by column. So it's these two for loops are basically the reverted version of these two for loops. And for the last one, it had to, so each task had to take the elements from k to k steps. And here as well, task number is basically, okay, this one uses the flattened form of the matrix, the one that I said I would explain later. And task number is basically the first element that should be taken from that flattened matrix. As you can see, I assigned it to start index. And then from that start index, it goes k steps and so on.
Just a moment. Current equals start index, current plus equals step, and the row is current over number of rows, and why is the row current over div number of rows and column is current modulo number of columns? Shouldn't be row current modulo.
It is
div number of columns.
Should it be divided by the columns? I have no clue. I thought it should be divided by the rows.
Because you have the linearized index and the column number is the linearized index modulo the number of the length of the row. That's the number of columns.
Yeah.
And the row number then would be the linearized index div the number of columns, the length of the row.
That's right, but for some reason it worked.
Probably you have square matrices.
Yeah, that's right. It's a square one. So it's 9 by 9. That's right.
Let's see a bit the main.
Yep. So for the main, I have some methods. As you said, I have the two matrices. They are 9 by 9. The first row, I let it a bit easier, so it's just a one followed by a lot of zeros, just to make sure that the result would be 1 to 3, 1 to 3, 1 to 3, whatever on the first row. And then I have all the methods basically. So I create, for each one of them, I create an array of runnables, and then I populate that array with either row tasks or call tasks or k-step tasks. Mm-hmm. And then I either run them in threads, which I have this method run in threads, which creates the threads, then logs the time before starting the threads and logs the time after they all joined, and then prints it and prints the result as well. And run thread pool basically gets the same parameters, also result and runnables, but in here it creates an array of callables because thread pools cannot get runnables as parameter. Then I create this executor service, and then again I log the start time, invoke all the callables, then shut it down and log again, and then I print the time.
Good.
So if I run it, then also it's split into 4 tasks. Yep. So if I run it, then the row tasks, the one in threads, this time seems to be a lot slower than the one in a thread pool. The call task is a lot faster, and the case step kind of the same as the call task. And I think it's because of how the caching works. Because in the row tasks, each time you iterate, basically for each element in a row, you take the whole column, but you cannot cache the whole column. So you have to take them one by one, and it caches row by row each time. While in the call task, by taking them column by column, you only have to cache the row once. So it's a lot less overhead with the caching.
Yes.
Yeah, so in here, instead of going column by column, so basically taking elements column by column, it takes the whole row, and it can process it element by element, which goes a lot faster than taking it elements from different rows, which goes faster. Yeah.
Good. Excellent, Ivan. Okay. Thank you. Next one, Septimiu.
Yes. I started now sharing.
Yes, I can see it.
Okay, I presented 2 weeks ago a version. This version I changed the locking to be for each account. Accounts now have their own mutex, public mutex, account mutex. And to avoid the deadlocks, I verify I sort them by the ID and swap them if by this comparator, and then I lock them in order.
If you swap them, you don't change the direction of the transfer.
I do, so I have this multiplier. And I added some additional safety measures. For example, the rollback, I made it to be safer with the try-catch. Meaning, I also use these flags to check the progress, how much I need to roll back. But I'm not really sure this is a good way. I also have another check when verifying the integrity. So there are no mutexes in the integrity check because it's related to the bank, but integrity check. I have in the bank a conditional variable, a mutex for the conditional variable, and an atomic bool to check if an integrity check is initiated.
Okay,
and I use the notify mechanism. In the transfer function, just let me find it, please. Okay, transfer range. So this is where I split them by an interval. Each thread has an interval of the whole transfer schedule. And this is where I call the transfer that I showed you before. But I check the atomic variable using the load to see if an integrity check is initiated. If it is, the threads fall to this weight. And only then the transfer, after they get notified, continues. Again, I know why this has problems, but I just tried my best.
Mm.
The problem is that
I don't understand why you should, and I think it's much easier to simply use the mutexes of the accounts as shown in the lecture. I guess it works this way because it postpones the audit till after the transfers are done, although I'm not very sure what happens if you have lots of transfers. Do you prevent? Yes?
Yes, I can tweak the parameters, and I have problems with large number of transactions and large number of threads. I get a crash.
Mm-hmm.
The thing I didn't check is that if there's a transfer already happening before after the integrity check is over, there could still be transfers happening. I can run it. I have some debugging thing here, but I counted the time. It decreases with number of threads. Well, not in this version, because printing, yeah, this is the crash. I have another branch in which I turn off all printing, and there I can see the time in milliseconds.
Anyway, it would be interesting to actually find and fix the cause of the crash. How to proceed? I suggest we stop here, and if you want to, I will see the other labs, and if you want to see together something related more in deep with the cause of the crash, then we talk later.
Sure, thank you.
Okay. And let's see, Flavio.
Eu aș mai avea de prezentat, dar chiar acum mă sunase curierul și trebuie să cobor până jos. Oare în regulă dacă revin în 5-10 minute? Îmi cer scuze. Mersi.
Okay, for your colleague, I think I will take someone else and come back to him, which means I will call him in private then. And unless you have some questions to ask now.
If I have questions?
Any one of you? Yes?
I don't.
Okay, then I